Hi, my name is Mr. Anderson. I am one of the UmptyUmp teachers. Today's lesson is on polygons. This first video is just an introduction to polygons. We're going to talk about some naming conventions, and we're going to talk about some regular polygons. Should be pretty quick. First up, naming polygons. You've probably seen the names of polygons before. You probably know, hey, 3 sides, it's called a triangle. 5 sides, a pentagon. It'd probably be a good idea right now to pause this video and see how many of these you already know. Okay, I'm going to go ahead and show you these, but there's going to be something more. We're going to talk about that. So here are all the names. Now we have the usual triangle, quadrilateral, pentagon, hexagon, and then all of a sudden we've got some changes. Some of you probably wrote heptagon. More of you, I'm thinking, might have wrote septagon. Those are both acceptable names. And we're going to talk about why there's a difference right now. There's enneagon for 9. I'm guessing more of you wrote nonagon or maybe didn't know it. And then there's a whole bunch of them for 11. Hendecagon, undecagon, unidecagon. There's a lot of them. But the reason for these different naming conventions is kind of weird, actually. Turns out that the ones I've listed here all have Greek roots starting at 5. Penta means 5. Hepta is Greek for 7. Those are Greek roots. Octa is Greek. Ennea is Greek. Deca, hendeca, and dodeca. Those are all Greek roots. The septagon name is actually Latin. Septa is Latin for 7. But it's kind of weird to combine them because gon is Greek. There is a common misconception here. A lot of people think pentagon means a 5-sided figure. It actually doesn't. The root word gon is Greek, and it actually means angle. So when we see pentagon, it literally means a 5-angled figure. Hexagon, 6-angled figure. And since these were all Greek, it was kind of weird to mix a Latin prefix with a Greek root. So slowly mathematicians are starting to kind of switch over to the Greek roots. So that's the reason for that change. Now, it's kind of happening slowly because people get stuck on there. As I will admit, for the longest time, I kind of liked septagon better than heptagon, but I've switched now too. I like heptagon better. Your book actually is in the middle of this switch. Many books, yours included, still use nonagon instead of enneagon, which is fine. I mean, it still means a 9-angled figure. It's just a Latin root mixed with a Greek root. While not always true, most books are starting to use heptagon. You'll notice these two are oddballs. They don't really follow the same naming convention. That's mostly because they are really common. Triangle literally means 3 angles, but angle is the American, I think that might be a Latin root instead of a gon. Tri is, I believe, Latin as well. And quadrilateral, that's a real oddball. Quad means 4. Lateral means side. Like that's the only one that's actually named on sides. Like this is literally a 4-sided figure. All the rest of them are named based on the number of angles. It makes no real difference. If we wanted to follow the Greek pattern that all the other ones are named after, they would have different names. They would actually be called a trigon for 3 angles with the Greek root gon, and a tetragon for 4 angles. Those ones will probably never change. Due to their common usage, these will probably never actually switch over to trigon and tetragon because everybody knows triangle and we've been using quadrilateral for years. My best guess, this might change over and become an enneagon because it's kind of an oddball being a 9-sided figure, and this one is already kind of in transition. All right, we should wrap this video up though. So, last thing, a regular polygon is a polygon with all equal angles and all equal sides, both. So if just because you have all equal angles doesn't necessarily mean you have all equal sides. Just because you have all equal sides doesn't necessarily mean you have all equal angles. I normally have kids here actually come up with examples of their own. I'll do one really quick. Create an example showing why a regular polygon isn't defined as a polygon with equal angles. That's easy. There's a rectangle. Clearly equal angles, but not equal sides. Create an example showing why a regular polygon isn't defined as only a polygon with equal sides. Sure, we can do that too. A rhombus has all equal sides, but clearly not all equal angles. So regular has both. Here's some non-quadrilateral examples if you like them. There's a regular hexagon, a regular decagon. But off to the side, I've got examples that aren't. This is a hexagon with equal angles, but not sides. If it has equal angles, there's a special word for it. It's called equiangular. If it has just equal sides, it's called equilateral. All right, that's it. Next video would be about finding the angles in a polygon.